Hello everybody, welcome to another lecture for CS2304. My name is Michael Irwin, and in this particular lecture, we're going to be talking about RBAC and Kubernetes. We've got a lot to talk about, but it's a lot of kind of theory and a little bit of what role-based access control is and how it fits into Kubernetes. And we're going to have a lot of slides to start off with, so fair warning. But then we'll get into a demo, and hopefully all the pieces will start to come together towards the end as we do the demo. So here's our goals and our outline for today. I'm going to start off first with defining what RBAC is, because I recognize many of you may have no idea what I'm talking about when I talk about RBAC. So we'll talk about what that is, how that's different than just kind of normal user authentication. And then I'm going to start kind of diving into the various components that Kubernetes offers. So we're going to talk about roles and cluster roles, and then RoleBindings and ClusterRoleBindings. And then finally, we'll talk about service accounts. And then at the end of the service account section, we'll do a demo and kind of bring it all together, hopefully, at that point. So with that, let's jump in, and we'll start with defining RBAC. So RBAC, in case you're not familiar, means role-based access control. And basically what RBAC is, if you think of authentication systems, there's usually two different components. There's one, authentication, of how do you actually authenticate somebody to know they are who they say they are, whether that's a person. So for example, I can log in through the Virginia Tech login, and I provide my PID, my password, and my two-factor login. And through that process, I'm authenticating. I'm proving that I am who I say I am. Okay? But once you've authenticated, then there's a whole set of authorization of what are you authorized to do. So as a faculty member, I'm authorized to access, my class rosters and input grades and lots of those kind of activities. As a student, you probably don't have those kind of access. So the authorization is very important, and it isn't tied to the authentication of how do I prove myself. They're two separate pieces. And so RBAC is very focused on the authorization side of things, of what am I authorized to do? What makes RBAC a little bit different than maybe some other approaches is that it's very role-based, in the sense that I'm not necessarily authenticating an individual person, but I'm creating this, you can think of it as a role. And so you can, actually the example that I just had a second ago, as a faculty member, I'm authorized to do X, Y, and Z. And so that means if, after I authenticate, if I am a faculty member, then I have authorization to do specific things, okay? And so there's various roles, and so we're authenticating the role rather than specific people within the role. And so that makes it easy to say, all right, somebody else is going to teach 2304. Imagine that we had to have a substitute, or somebody swapping. They can just swap out who's in that role without having to go figure out what are all the different permissions and things that person as a person needs. And then if you ever do anything with identity systems, this is very much how most systems work, that it's very role-based. And so you create roles of, okay, as a software developer, you have access to systems X, Y, and Z. And so you may have a team of people, and so everybody on that team that has the same role has the same permissions to things, and again, it allows you to kind of onboard and offboard people much easier. But the thing is we can authenticate more than just people. We can authenticate applications, because applications serve a role as well. Whether it's a dashboard to display information, or I've got some other examples here. Or, we talked about ingress last week. So if I have traffic running, well, it needs to be able to monitor the ingress object. So how does it get permission to monitor that? But I don't want it to be able to view all my secrets in my cluster, for example. So how do I create that permission policy to let it do the things it needs to do, but not more than that? And there's some other examples here as well too. So again, it really gets down to how do I define permissions for a role and then grant that role to the subjects. And that's pretty much what we're going to be talking about today. So in the context of Kubernetes, we frequently need to answer questions. So for example, what namespaces can a role access? If I'm running multiple applications for multiple teams, I may want to say, hey, team A, you have access to namespace A, but you can't access namespace B. So how do we do that? What resources can a role access? So should you be able to access all the resources or just a subset of them? what operations can you perform on them? So for example, one of the things that we do in our platform here at Virginia Tech is we grant read-only access to all of the applications teams, because we're basically forcing all the changes to go through a GitOps flow, which I'll actually talk about in another week or two. So our platform tenants have read-only access to their clustered or to their various namespaces, but as an administrator, I've got a little bit more permissions. Okay, we still don't give out full permissions without some process in place, but anyways, we might want to be able to answer those questions. And again, like I talked about earlier, roles can be other applications or users or people. So again, we want to think very role focused, role centric as we're working through this. Okay. So I talked about earlier how auth systems have those two different components. There's the authentication. How do I prove the identity of a person? And then what are they authorized to do once I know who they are? Kubernetes actually has really no built-in mechanisms to authenticate people. Okay, it does have ways to authenticate applications, which we'll talk about with ServiceAccounts. But to authenticate people, well, there's a variety of ways to authenticate people. You can have social logins. You can have, for example, here at Virginia Tech, we've got actually quite a few different protocols that we can authenticate people, either through LDAP or CAS or even OAuth, OIDC gateways. There's a lot of different ways to authenticate people. And there's Active Directories. There's just so much out there. So Kubernetes said, we're not going to get in that business, but what we will do is we'll make a mechanism so that you can run an application that can do the authentication, and then through impersonation, you can make calls to the API in behalf of the user. And so it allows this proxy to basically pass to the API, hey, I'm making this call in behalf of this user who's in these groups. And then, as the second bullet point has here, Kubernetes has a pretty robust authorization system to say, what are you allowed to do now that we know who you are? Okay, so it allows you to kind of swap out how authentication works. Okay, I want to do LDAP, I want to do CAS, I want to do SAML or OIDC, all the different protocols out there. I can run an application and something that knows how to do that, and then it impersonates that against the Kubernetes API. And that's pretty much how it works. Okay. If anybody's interested in learning more of how to actually set that up and whatnot, feel free to reach out, and I'd be happy to show off a little bit of how we're doing things, how we're doing that in the platform clusters that we're running. So let's talk about roles and cluster roles. So roles and cluster roles think of them as they're the permission set. It's the permission policy of what are the things that you're allowed to do. And it's just the policy. It's not actually applied to an actual role, even though it's called a role. It's not applied to subjects like service accounts or people, etc. It's just the permission policy. And so the way that the authorization system works is that it's a deny all by default, minus a few exceptions, but it's pretty much deny all by default. And then you have roles and cluster roles that grant access back to you. Let me grab the laser pointer here. Where'd you go? There. Okay, so this role, for example, here is a role that we're naming pod reader. It's in the default namespace. And the rule says I'm going to grant get, watch, and list access to pods. Okay. And I'll have the next slide will give some more verbs of the things that we can do. And so that's what a role is. Now, the difference between a role and a cluster role is important, okay? So a role is a permission policy that's defined within a namespace and is only accessible within that namespace. And we'll talk about role bindings here in just a minute, but that's what, excuse me, the role is what defines that permission policy, and a role stays within that namespace. A cluster role is a permission policy that's accessible across all namespaces, okay? But then it can be applied within a specific namespace or across the whole cluster, and that'll make sense here in a few minutes, okay? So again, roles are defined within a namespace and grant access within a namespace. Cluster role is defined at the cluster level, but again, when we talk about bindings, we'll see that it can be applied either within a namespace or across. And cluster roles are really important if you want to, so going back to our tenant example earlier for our platform, we want to make sure that all tenants have the same set of permissions. And so we define that at a cluster role to say, here's the permission set for a tenant in our platform, okay? And then when we talk about bindings in a few minutes, we'll take that cluster role and then we'll say this tenant is going to use this role, but it's confined, it's kind of scoped within this namespace. Okay? Again, it'll make sense in a few minutes. Okay? So the anatomy of a role, cluster role, every role contains a set of roles, and again, that's what's being listed here. So the API group of the resource, and it doesn't include the version. So pods, when we put the API group, it's just v1, okay? But really, it's actually, since it's v1, v1's the version, and since it doesn't actually have an API group, it's part of the core group. But like for example, when we talked about let's pick deployments, okay? So it's apps/v1. So the API group here for deployment would be apps. Okay. Then we list out the resources within that API group. So again, if I wanted to do deployments and replica sets, for example, I would have the API group as apps, and then resources would be deployments and replica sets. Okay. And then the verbs can vary a little bit depending on the resource, but these are pretty common ones that are available in all of them. So get, list, so that will list them all. Watch will let me watch for events and watch for changes, so I don't have to keep just getting. Create, can I create instances of that resource? Can I update? Update and patch are quite often the same thing, but a little bit different. I won't get into it, but and can I delete? Pods also have additional ones for like exec. Can I exec? And actually, that's a different resource, but anyways, there's quite a few different things that we can do there. And roles are, since again, roles are defined within a namespace, either have to have the namespace selected or just whatever when you apply the manifest using kubectl, it'll just use the namespace that you're in. So again, they're going to be defined within a namespace. All right. So system defined roles, there's quite a few that come along with Kubernetes. In fact, there's actually a lot. And in fact, maybe let me just switch over to Chrome here, and default roles and role bindings. This page is quite large, and it talks about there's system basic user and discovery. There's user facing roles, which I'll just talk about in a minute. So I can say cluster admin or admin. I have edit access, view. And then there's a lot of these other ones, okay, a volume scheduler and a system node and node proxier and kubedns, and there's just a lot of kind of default ones for various subsystems within Kubernetes that you may or may not ever need to use, kind of thing. Okay, now so one of the nice ones are, so these user-facing roles, cluster admin, admin, edit, and view, these are special ones in the sense that they're kind of defined and intended not for applications, but for users that might be doing this. So for example, if I were a cluster admin and I want basically full access to everything, I would grant cluster admin. Now, if I wanted to administer a particular application, as it says here, it allows admin access intended to be granted within a namespace, and this role does not allow write access to resource quota or to the namespace itself. So basically, it doesn't allow you to change how the namespace is structured and the limitations of it. Now, I may be, and we haven't talked about CRD's custom resource definitions yet, but I may need to enhance what the admin role allows me to define. So what I can do is I can actually make my own role that adds these additional labels, and when I put these labels on it, it kind of gets merged into. So in this case, if I did aggregate to admin true, then the admin policy would have the additional things that I define another role. In fact, I've actually got an example on the slide here. So in this case, I'm using a custom resource definition from a tool called Cert Manager that allows me to ask for to get certificates. Okay, so the API group is Cert Manager, and I'm going to allow get, watch, and list, and I'm going to aggregate to view. So now if somebody gets the view role granted to them, they can also have permission to get, watch, and list certificates. Okay, so it might be something helpful for you. You probably won't run into it too much, but it's good to know that it's there. So just remember that it's there. Okay. All right, let's talk about role bindings and cluster role bindings now. So the roles define the permission set, and then the role bindings are what attach those permissions to things. Okay, whether they're applications that are running or people. Okay, and the difference between a role binding and a cluster role binding is the scope for which it's accessible. The permissions are being applied. Okay, so a role binding, just like a role, applies permissions within a specific namespace. So it says you're authorized to see pods within this one namespace. Okay, now the permissions that the permission set can either be defined at the cluster level or a role, but it's only going to be applied within a specific namespace. Okay, and again, the use case of having a cluster role that keeps the permission set the same across all namespaces is very valuable in this exact use case here. A cluster role binding will then say, hey, I'm going to grant this permission across the entire cluster, so across all namespaces. So for example, if I wanted somebody to be able to see all pods across all namespaces, I would create a cluster role binding that references a cluster role that gives them pod, get, list, and watch verbs to it. Okay. Now, so the anatomy of a cluster role binding, and we'll see an example of this here on the next slide, is a role binding has to specify a role ref. So what permission set are we granting, and then specify the subjects of who are we granting them to. And those subjects can be service accounts, groups, or users. And we'll see some examples of that here in just a minute. So here's an example. All right, I've got a cluster role. Again, it's going to be defined at the cluster level. And this is going to grant get, watch, and list to pods. Okay, so very similar to what we were just looking at earlier. Now I'm going to use a role binding to grant this cluster role. So again, this permission set to any user that's in this group. So IDC platform example admins. And again, this would go through like an impersonation type thing. And we'll see another example of that here in just a minute. So any user that's in this group, okay, would effectively have the cluster role binding. But since this is a role binding, it's going to be scoped to the namespace of example app. Okay, so I hope that makes sense. I've got this cluster role again that's defined at the cluster level, and it's going to grant access to users in this group, but only to this namespace. Okay. All right. So let's talk about service accounts for a minute, and then we'll do a demo and kind of bring it all together. So service accounts are a way that Kubernetes gives identity to processes that are running within a pod. Okay. So it's a way to kind of for the pod to identify itself, to say, yes, I am this application, I'm this role. And that role can be then granted permissions. So for example, if I were running a Kubernetes dashboard, well, it needs to be able to query what pods are running and volumes and deployments and all the different things. Well, how does it authenticate? Well, that application can authenticate by using the service account and saying, I am the dashboard. And then the authorization that role bindings can say, hey, the dashboard service account has access to to all these different capabilities, these different features. Okay? All pods have a service account by default, but the default service account grants no permissions. It's just an identity thing. And you can create your own service account, which again we'll do here in just a minute. And then we specify the service account by setting the service account name on the pod spec. Okay. The way that it works is that when we create a service account, there's actually a Kubernetes secret that gets created that has a token in it. And this token is what's called a JWT, a JSON Web Token. If you're not familiar with what a JWT is, you'll see one in just a minute as well. And this JWT identifies the service account. Okay. And then that pod can take that token and pass it to the API, or it can pass it off to other services to authenticate and perform various functions. The token, since it's a secret, is mounted in just like when we were talking about secrets and configuration a couple weeks ago. And and it's mounted in just like this. So the service account token is a secret that's mounted in, and the default location is at var run secrets Kubernetes IO service account. And this is a directory, and so inside this directory will be a slash and a file name token. And again, we'll see an example of that here in just a minute. Okay, so service accounts, again, are just a way for pods to have an identity, okay? And then we can use the roles and role bindings, all those mechanisms to then grant that identity permission to do stuff, okay? So with that, hopefully you've kept up so far. And I know it's a lot of information and everything, so let's jump into a demo here. What we're going to do is I'm going to show off what we're going to be doing here first. So the first thing I'm going to do is I'm going to create a service account. And creating a service account is actually really easy. It's exactly this. So I specify the API version, the kind, and the name. Okay, I'm going to deploy this into the default namespace. And then what I'm going to do is I'm going to make a role, which looks very similar to the one that we have in the slides because I copy and paste it. Other than the fact that I changed the namespace to default. So I can get, watch, and list pods. Okay. All right, if I scroll down a little bit, I see a role binding here that's going to connect the pod reader role that we just defined above to the service account that we also just defined above. Okay. And then I'm going to run a pod, an Nginx pod, and I specify the service account name of test here. Okay. So if I take a step back, I create a service account, I create a role that grants the ability to read pods, and then I attach that to my Nginx container here. And so when I start Nginx, I'll be able to see I'll have that service account token for test, which if I use that token, it should be able to authenticate with kubectl and go from there. So if I could spell apply right, let's apply this, get everything running. And what I'm going to do is exec into that container. And I'm going to install kubectl, and I'm going to just pull one of the releases here, and I'm going to save it at user local bin kubectl. This will take a second to download. I know this is an older version of kubectl. I'm just copy and pasting off of a website here, but that's okay. And we'll change the permissions on it so that I can execute that file. And now, if I do kubectl get pods, what happens is kubectl recognizes, hey, I'm running within a pod, and the way that it does that, it sees some of these environment variables here, and it then knows, hey, the service account token is where I expect it to be, so let me use that to authenticate against the cluster. Okay, so let's actually go look at the service account token. So var run secrets Kubernetes service account, and if I cat the file, I get this. And I know some of this is kind of combining it together. So let me take this, and you may not know what a JWT is, so let's jump over to Chrome, and I'm going to open up jwt.io. And this website is fantastic because it allows me to put a JWT in, and I'll explain what a JWT is in just a second. But I could put an encoded JWT here, and it will break it down and tell me what's in here. And it does it all just here in the browser, so I don't have to worry about it sending my token off somewhere else. So what a JWT is it's a 3-segment token. Okay, and each segment is separated by a period. So the first segment is base 64. Actually, the first 2 segments are base 64 JSON encoded data. So if I take this and base 64 decode it, I get this JSON structure here, which tells me an algorithm, which I'll explain in a second, and what's called a key ID. And so this is a key ID of some sort. This middle section, so the first section is called the header. The second one is called the payload, as it says here. And so the second section here is also base 64 encoded JSON data. And if I look at it here, it tells me a lot of information here. So the audience is, who who or what the token is intended for, an expiration time for this token, the issuer, and it includes information such as the pod, who has this token, the service account. So the service account is test, the subscribers. So it gives me a lot of information to identify the pod. And with this last segment here, this blue part here, is a cryptographic signature over the previous two spots. Okay. So what this means is if I could get access to the public key that this key ID is referencing, which I'm not going to go through right now, but if I got the public key, I could basically run through this RS-256 algorithm with the public key, and the signature should match. And what that means is if anybody were to get this token and say, well, hey, I want to try to change, and so now I'm going to make myself an admin, for example, which this doesn't know how to sign it right now. But if I change this, then the signature is not going to match, and so I know that this token's been tampered with, and I'm going to throw it away and not accept it. Okay, so that's the beauty of JWTs here. Okay, and JWTs are used all over the place now because they're really compact, and they provide a lot of information, and then are also cryptographically verifiable, which is really, really cool. So, the Kubernetes API allows me to take this token, and yeah, it's technically the one that issued it, so it can validate it really quickly. But it accepts this token and validates it and knows, okay, I have got the service account, and now what is the service account authorized to do? Now, so one of the things I'll mention here real quick is, let's go back to my terminal here. So I can do a kubectl get pods. Now, so I granted the service account access to only look at pods. Now, Docker Desktop does something honestly a little funky. If I ask for services, that should have been blocked. Okay. And the reason why is because Docker Desktop's doing something, again, a little funky here. So one of the things, if I look at the ClusterRoleBindings, and I should have grepped for Docker, we'll see that there's a ClusterRoleBinding that they've created that's called Docker for Desktop Binding here. Let's describe that. And what we'll see is that it's authorizing system service accounts cluster admin. Okay. Now, if you probably don't know what service accounts is, so let's jump over to Chrome here, and we'll look at the documentation. If I do system service account singular is the prefix for service account username, system service accounts plural is the prefix for service account groups. Okay, interesting. So let's, if we scroll down a little bit more here. Okay, so for all service accounts in the QA group in any namespace, okay, so system service accounts QA would then, that could be a subject. And what this tells me is for all service accounts in any namespace. So if I use a group of system service accounts, any service account will be the subject. Okay, so if we jump back to the terminal here, what this is saying is all service accounts in the cluster have cluster admin rights, which honestly, I'm not 100% sure why they're doing it this way. I think it's just to make permissioning a little bit easier in local development where, for the most part, permissions don't matter. But so one of the things I'm going to do here is I'm going to make a backup of this ClusterRoleBinding so I can restore it, and then I'm going to nuke it. So that way I can actually test out the permissioning here. So I'm going to get the ClusterRoleBinding. Okay, of the, oops, there we go. I pressed tab one too many times. Okay. And I'm going to get it in the YAML output, and I'm going to save it as a YAML file called full binding. And so that way, when I delete this, I can restore it later. All right. Now I'm going to delete that ClusterRoleBinding. Docker for desktop binding. And now if I go back into my pod, I should still be able to get my pods. But now when I get my service, now I get my deny message. Okay. So now I can see that, hey, I'm not authorized to make that call because I removed that kind of default every service account gets everything. And I should make clear, that's only a Docker desktop thing. Normal Kubernetes clusters do not have such a role binding. That would be a pretty bad thing to have in your cluster. So we see that the permissions got denied. Hooray. Now, so one of the things I can do too is, let me get this token again. And, okay, back on my cluster, or my outside of the container, I can do a kubectl config, and I'm going to set credentials for a user that I'm just going to call service account test. Token equals that service account token. Okay, so then it says, hey, this user SA test was created. And now what I'm going to do is kubectl config set context user equals SA test for the current context. Okay, and I know I haven't talked much about context, but basically what I'm doing is I'm updating my local kubeconfig to now use this token to authenticate, or to use that to authenticate against the Kubernetes API. So now if I do a get pods, I still get that, but now if I do a get service, I get denied as well. So I've basically taken that token, in this case, outside of the container, and now I'm using that here on my machine. I could actually do the same thing. Let me just close one of these out. If I list the secrets, which I won't be able to do now, so let's revert this back. Change my user back to Docker desktop. If I list the secrets, I'll see a secret here for a service account, this test token here. Get my secrets. We'll see a token here. Okay. I'll have to echo that. And then base 64, decrypt it. And now, and then I could, do my config context setup that way too. So a lot of people, if they're trying to test permissions or that kind of stuff, especially where you don't have user impersonation set up, you can do exactly this. So you can create a service account, give it the various roles and bindings, and then kind of test things out with it. So, and with that, actually, before we do that, let's go to our last one. So for the hands-on this week, what we're actually going to do is we're going to launch a Kubernetes dashboard, and we're going to play with various ways to configure the dashboard and different service accounts, and then you can actually see some visibility into what's running in your clustered environment. So it should be pretty fun. It shouldn't be too hard to do. And honestly, at the end of the day, you don't have to know a ton about the permission and all that kind of stuff. You'll get a lot of hands-on practice with it once if you ever become a Kubernetes administrator and do more with it. But again, for the most part, this is hopefully just exposure to here are roles, here are bindings, and here's how they apply to the service accounts. And again, hopefully the hands-on this week will give you more opportunity to try things out and get a feel for how it actually works. So, as always, if you've got questions or feedback or anything I can do to help out, feel free to reach out to me. And otherwise, hope you have a great rest of your day, and I will chat with you later. Thanks.